some willingness by somebody to give up Reese's for more hugs. Who here likes Reese's and well, I've got Kit Kats. Reese's and Kit Kats. I need one person. You're close. Come on up. All right. How are you? I'm Max. Nice to meet you. Come on up here. All right. So Angelica, I'm going to confront you with some bundles here. Reese's. So 1, 2, 3, 4, 5, 7, 9, 10. How about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Kit Kats? 10 each. Stare at it for a moment. And envision how good you would feel if you and your friends could consume those Reese's and Kit Kats. And sort of feel that level of happiness that you get, right? The sort of warmth that the chocolate, spills over onto your soul. You got it? All right. Here's what I'm going to do, okay? I'm going to take away 3 Kit Kats. Don't cry, okay? 3 Kit Kats. Now you've got 10 Reese's and 7 Kit Kats. I'm going to add Reese's, right? Slowly. And you're going to tell me when I've restored your level of happiness from the 10-10 scenario. You got to be honest, though, because I'll just keep on going. There's a way to game this one, all right? You're good? Okay. Let the record reflect that we are at 13 Reese's and 7 Kit Kats. Okay, I'm going to restore the original level of happiness here. I'm taking away 5 Reese's now. This is getting serious. Okay? Let me add Kit Kats slowly, and then you tell me when you're just as happy as you were with the 10-10 scenario. You're good? All right. So 3, I should have counted. 6, 9, 12, 15, 16. Okay? So you wanted 6 more Kit Kats for the 5 Reese's I've lost you. So here. You get to take all of these. You don't have to consume them all yourself, because I don't want to be accused of force feeding individuals too much chocolate. But there you go. Thank you very much. All right. So that was a good performance, I thought, too. Oscar-worthy, right? So all I'm trying to demonstrate with this thing here, which we've already sort of done before, is I'm arguing that for some goods, you're willing to substitute more of one for less of the other. You're willing to give up some Reese's for some more Kit Kats, and you're going to maintain your level of happiness, right? You're just as happy with a lot of Kit Kats and a few Reese's as you are with a lot of Reese's and a few Kit Kats. So what that means is there's some willingness to substitute between 2 goods, right? In reality, you're willing to substitute between hundreds of thousands of goods, but I don't know how to draw in a 100,000 dimensional space. I know how to draw in 2-dimensional space. So we're going to keep this simple, and I'm going to argue that these downward sloping indifference curves that I'm drawing here, I'm going to have to erase this. Every time I look at it, I get angry. There we go. So what the downward sloping indifference curves tell us, or capture really, is the fact that for many goods, we're willing to substitute more of one for less of the other, right? There's some willingness to trade off while maintaining our level of happiness. Now, what does that mean? That means, not for all goods, right? For some goods, and I'll give you an example of those, you're not willing to substitute, but for a lot of goods, you're willing to substitute between these two. The question that becomes really interesting is at what rate, right? At what rate were you willing to exchange peanut butter cups for Kit Kats? Meaning how many peanut butter cups were you willing to give up for one more Kit Kat? Right? If you really don't care so much for peanut butter cups, but you care a lot about Kit Kats, right? I'm going to have to give you a lot of peanut butter cups in exchange for one Kit Kat that I take away from you. If you're the type of person that's crazy about Reese's but doesn't really care about Kit Kats, I'm going to have to give you a ton of Kit Kats in order for you to give up one more Reese's. So your willingness to substitute between these 2 goods right here really depends upon how much additional happiness you get out of one of these units, one additional Reese's or one additional Kit Kat right here. So again, the willingness, this marginal rate of substitution here, which is this exchange rate between peanut butter cups and Kit Kats here, depends fully upon how much you like these goods relative to each other. And we're going to explore that in more detail. But this thing here, this marginal rate of substitution, which is one of the most important concepts we'll study in the next week or 2, simply is the exchange rate of the good on the y-axis, right? Give up one of the goods on the y-axis for more goods on the x-axis. Now, the change in y over the change in x, that you remember as the slope of something, right? It's rise over run. How many Reese's do you drop by in order to gain an additional number of Kit Kats and remain on the same indifference curve? So the marginal rate of substitution really is the slope, the rise of the run of that indifference curve, and that captures how willing you are to trade off between Reese's and Hershey's. So I'm going to often say the same thing 2 or 3 different ways, and that's not because I can't remember what I just said. I'm not that old yet. But I'm thinking that over time, if I say the same thing in 3 different ways, everybody understands things differently. So if you understand it the first way I've explained it, just zone out for the other 2. But if I say things slightly differently, I get better coverage and understanding in the classroom, right? So marginal rate of substitution is either the slope of the indifference curve, or it is the exact number of Reese's you're willing to sacrifice in order to get a larger number of H, right, of Hershey's here. Now, one thing we're going to note is, and I'm going to show you in a second here, is that marginal rate of substitution for most indifference curves isn't constant. It changes depending on how big your stash of Kit Kats is relative to the size of the stash of Reese's, right? And we're going to relate this to something called marginal utility, which you might remember from Econ 1, but we're going to get there, all right? So marginal rate of substitution isn't a fixed number, but it's going to depend on how big the size of your relative stash of the two goods is. What on earth are you talking about, Max? Let me show you, all right? This is good stuff. I'm going to sit when I draw, because I'm really tall and I just can't reach down that far. All right, here we go. Let's draw an indifference curve. The indifference curve I want to think about is we have Reese's up here, and we have Hershey's down here. The indifference curve starts at bundle 10.3, goes through bundle, this is 7.4. This thing's going to go out the window in a second. Last time I broke one. There's a surface 1 somewhere that didn't make it through IAS 106. 7.4, and then we've got 5.5, and we've got 4.6. Okay, now let's see if we can draw a nice indifference curve through these points. Call this indifference curve 1. There will only be 1 on this particular graph. I'm going to use the big dot theorem, which just means I can't draw very exact. Okay, so this is an indifference curve. Do we like it? We love it. It's downward sloping, it's thin, and it doesn't cross any other indifference curve because I failed to draw other ones. All right? So this is my downward sloping indifference curve for one individual. Let's call this guy Max, between Reese's and Hershey's for a certain level of happiness. All right? So let's figure out, start him out at an initial bundle 10.3. And what I'm going to do is I'm going to remove I'm going to give him one more Hershey's, right? I'm going to move him from 3 to 4, and I'm going to see how many Reese's he's willing to give up for one more Hershey's while maintaining his level of utility. So he stays on the same indifference curve right here. Right? So he went from 3 to 4 Hershey's, and he gave up how many Reese's? 3, right? Did this thing just eat it again? There must be some auto-save. Oh, there you go. Thank you for bringing it back. Okay, so from 10 to 7, so the change in Reese's is minus 3, right? I give up 3 Reese's. The change in Hershey's is how much? Well, change in Hershey's equals 1. Now let's do the next step here, right? Now let's start at this point here. Let's call this one B. Let's call the first one A. Let's move to point C. Point C increases the amount of Hershey's again by 1 unit. So change in H is exactly 1. How many Reese's did this individual give up now? 2, right? I'm assuming this is going to come back the line I just drew. Change in Hershey's is minus 2. Of course, now it doesn't come back. Thank you. Oh, there we are. Okay, so when we went from A to B, I got 1 more Hershey's. I was willing to give up 3 Reese's. Now I went from B to C, where I started at 7, 4. I got 1 more Hershey's, 5, and I'm only willing to give up 2 Reese's. And that thing should be an R, not an H. Right? Willing to give up 2 Reese's. Now let's go from C to D. This gets boring very quickly, but again, I'm adding 1 more Hershey's. And how many Reese's is this individual willing to give up? 1. 1, and here the change in R is minus 1. Thank you. Okay. So, I can't swear in class. That would just be totally inappropriate. But just make up your favorite swear words and imagine I'm saying those. So 7, 4. I'm going to fix this till next time, I promise. 5, 5. Maybe I'll fix it by throwing it out the window, but this won't happen again. Okay, that's my indifference curve. But what we drew here is when we went from A to B, B to C, and C to D. Right here, the change in Reese's was minus 3. Here, the change in Reese's was minus 2. And here, the change in Reese's was minus 1. The change in Hershey's, don't touch a ball, does that, Max? That's good. Now it's screwed up the resolution. This is fantastic. Change in H is 1. Change in H is 1. Change in H is 1. So I told you that the marginal rate of substitution is the change in Reese's, the number of Reese's you're willing to give up in order to get 1 more Hershey's. So if I go from A to B, I'm willing to give up 3 Reese's in order to get 1 more Hershey's. So rise is minus 3, run is 1. So the marginal rate of substitution, rise over run, is going to be minus 3 for a move from A to B. B to C, I was willing to give up 2 Reese's, so rise is minus 2. In order to gain 1 more Hershey's, run is 1. So minus 2 over 1 is minus 2. The marginal rate of substitution from B to C went to minus 2, which is different from minus 3, I hope you realize. C to D, now I'm willing to give up 1 Reese's in order to gain 1 more Hershey's, so rise is minus 1, run is 1. The marginal rate of substitution is minus 1. So as we're moving from Seattle to Miami, Florida on this indifference curve right here, right, from the top left to the bottom right here, the marginal rate of substitution goes from a large negative number, so MRS is equal to minus 3 here, the MRS is equal to minus 2, to minus 1, it goes to a smaller and smaller negative number. So what, for this nice bowed out indifference curve here, I'm saying is that your willingness to give up Reese's for 1 more Hershey's diminishes. As your stash of Reese's shrinks, right, gets smaller and smaller, you're willing to give up fewer Reese's for 1 more Hershey's, because at the same time your stash of Hershey's is increasing. And we're going to relate this later to this concept of marginal utility, which you may remember, but you don't have to. Okay? So for these bowed out indifference curves, the marginal rate of substitution is not constant, but it becomes a smaller negative number as we go along the indifference curve. Okay. Now, do all indifference curves look like that, right? Where you're willing to substitute at these rates? The answers are no. Meet Max. Max is a nice guy. He would like to drink German beer all day long, but then he couldn't teach, and it's not good for you anyway, so I drink a lot of water. And I don't really care whether I drink Arrowhead, Dasani, Fiji water, this weird Finnish Voss water for $19,000 in a 15-pound glass bottle that we're shipping across the globe. I don't care. Bottled water to me is bottled water, right? Doesn't really matter what container it comes in. So to me, Arrowhead and Dasani are 2 brands of bottled water. They're perfect substitutes, right? So if I put Arrowhead, let's call it A, on the y-axis, and Dasani on the x-axis, I am indifferent between having 5 bottles of Arrowhead and 5 bottles, let's assume they're the same size, 16-ounce bottles of water, or 4-1, or 3-2, or 2-3, or 1-4, right? I don't care as long as I have the right amount of water. Arrowhead and Dasani are perfect substitutes for me, 1 for 1. So whether I have 10 bottles of Arrowhead, 10 bottles of Dasani, or 5 each, doesn't matter to me, really. They're perfect. Oh, good job. That's new. There we go. It's amazing. So not, the drawing ability has gotten better from Surface 1 to Surface 3, but it has some new moves. I went to dance school. All right. So here, 5, 5. I clearly am indifferent between all of these combinations, right? As long as the total amount of water adds up to 80 ounces, 5 times 16. Here, I don't care whether you give me 5 of each, or 10 of one, none of the other, or none of one and 10 of the other. Doesn't matter what the mix is. So imagine Max goes to the supermarket. Arrowhead and Dasani are both on sale. $1 a bottle. I'm going to use both hands, and I'm just going to throw random bottles into my shopping cart until I've got the number I want. I'm willing to trade them off 1 for 1. So what's the marginal rate of substitution for these perfect substitutes, Arrowhead and Dasani? How many bottles of Arrowhead am I willing to give up to get 1 more bottle of Dasani? 1, right? So the marginal rate of substitution here is 1, and it's constant. It doesn't change along the indifference curve. Rise over run along a straight line, no matter whether I'm up here, and I'm moving from A to B, or I'm down here, and I'm moving from C to D. The marginal rate of substitution is equal to minus 1. Right? I'm always willing to trade more Dasani, more 16-ounce bottles of Dasani for 1 fewer bottle of Arrowhead, 1 for 1. So the important insight here is the marginal rate of substitution is constant for perfect substitutes, but it's not necessarily minus 1. Right? So let's say I don't care about convenience of a 32-ounce bottle and a 16-ounce bottle. I could be indifferent between a 32-ounce bottle of Arrowhead and 2 16-ounce bottles of Dasani. Right? How many bottles, if Dasani comes in 16-ounce bottles and Arrowhead comes in 32-ounce bottles, how many bottles of Arrowhead am I willing to give up for 1 more bottle of Dasani? Dasani's the smaller one. There's two possible answers. Who here thinks it's a half? That's the right answer. So I think it's a half, right? So who here thinks it's 2? That's the wrong answer. Think about it again, all right? So the notion here is if Arrowhead comes in, let's use metric system, 2-liter bottles, right? And Dasani comes in 1-liter bottles, I'm willing to give up half of a 2-liter bottle of Arrowhead for one more 1-liter bottle of Dasani, or I'm willing to give up one whole Arrowhead 2-liter bottle for 2 1-liter bottles of Dasani. So the marginal rate of substitution there would be minus a half, all right? But it's constant along the indifference curve. So these goods are called perfect substitutes. I'm indifferent between them at a fixed rate, constant exchange rate. How about perfect complements? So I turned 40 a little while ago. Actually, it's been more than a little while ago. And then they tell you can't drink caffeine anymore, and turn down on the sugar, and you should lose some weight, and you should exercise, all these horrible things. So now I have to drink decaf coffee. I don't like it, but I'm doing it. So perfect complements. I'm putting cream in my coffee no matter what the doctor tells me, because coffee without cream is gross to me. That's my taste. So to me, the perfect combination of coffee and cream are about, for each 8-ounce cup, I like one of these little creamer things, right? So I go to the store. Starbucks has too many choices. I can't handle it, right? I like, sell me a substance called coffee and some standard creamer with a gold label. I don't even know what the brand is, right? So I go in there. You sell me an 8-ounce cup of coffee. I will go to the free stand, and I will pick exactly one little plastic container of creamer, and I will pour it in my coffee, and that's the exact perfect way I like my coffee, all right? If you give me an infinite number of additional creamers, am I going to put 42 creamers in my coffee even though they're free? No, right? Who here knows exactly the way they like their coffee? I know it's lunchtime, you guys are hungry, but raise your hand. Everybody does, right? How do you like your tea? You know exactly how you like it, right? And you're going to put in the number of packets of sugar and creamer in the way that you exactly like it. So that means your level of utility is sort of maximized for an 8-ounce cup of coffee when you've got the exact right amount of creamer. So for me, this goes, let's say this here is coffee, and this here is cream. So let's say coffee here is measured in 8-ounce cups, and cream is measured in those little plastic things. So for each 8-ounce cup of coffee, I want one exact unit of creamer. Now, if you give me a whole bunch of coffee, and you give me no more cream, I'm not going to be any happier, right? So if you hand me one packet of cream, and there's the all-you-can-pour coffee on the side, I'm going to pour myself 8 ounces of coffee, and I'm going to put in one more creamer. I don't have any more creamer, so I don't get any additional utility out of any more coffee, right? You can throw as much coffee at me as you want, but I'm not going to be any happier. I'm indifferent between my 8 ounces in one cup of creamer and 100 liters in one little creamer. Now, same thing goes is if they pour you the 8-ounce cup of coffee, and that's what you see more frequently at gas stations or things like that, they pour you the 8-ounce cup of coffee, and then there's like a big jug of creamer, and you always wonder how long that's been there, right? There's like 100 of them in a little cup of ice, and why don't people just grab 100 of these and dump them in the coffee? It's more stuff. Well, you like 1 creamer or 2 creamers to your coffee, right? Unless you give me more coffee, I'm not going to care. So you're indifferent between a lot of coffee, there's a binding thing here, which is the number of creamers, and 1 creamer, or lots of creamers and 1 8-ounce cup of coffee, right? How do you get made happier? Give me more of both, right? If you give me 2 units of coffee, 16 ounces, that's, I do that before breakfast, and 2 creamers, my perfect complements are 0 Microsoft Surface products and 1 chalkboard. Okay. So let's assume this is going to come back now that I draw to it. You give me 1 more coffee, and creamers are still free, all right? So I'm going to mix 16 ounces of coffee with 2 creamers. Again, if you throw more coffee at me, or you make it available to me, I'm not going to take any more, because more coffee is going to dilute my creamer in ways that I don't like. Or if you give me more creamer and no more coffee, again, I'm indifferent because it'll make it too creamy and fatty, right? So I prefer indifference curve 2 to indifference curve 1, right? Because on any ray from the origin, remember that? Indifference curve 2 is further away from indifference curve 1. But I like my goods in fixed proportions. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and you could just keep on drawing these L-shaped indifference curves, and these L-shaped indifference curves are called perfect complements, or fixed proportions indifference curves. That's if you like goods in fixed proportions. Coffee and cream, shoes and shoelaces, French fries and ketchup, or mayonnaise if you're Dutch, right? So certain goods you like in fixed proportions, and you're not willing to substitute between the two. So for fixed proportions indifference curves, what we argue here is that there is no marginal rate of substitution, right? Because you are not willing to substitute more cream for more coffee at any level of happiness because you like them in these fixed proportions right here. So you say there either is no marginal rate of substitution or the marginal rate of substitution is defined, right? The marginal rate of substitution earlier we showed is the slope of our nicely shaped indifference curve versus does this thing with a corner have a slope? Now, you might remember from calculus there's something about continuously differentiable. You can figure out a line through every point. Can you figure out a distinct line through a corner? You can't, right? So the marginal rate of substitution is simply not defined. If you on the exam say it's 0, I can live with that, all right? So that's perfect complements. So we had perfect substitutes, if you're willing to trade them off at a fixed rate. You had perfect complements, which is if you need them in fixed proportions. And then last but not least, by no means the last slide in this exciting presentation here, is imperfect substitutes. Now, for those of you who drink wine, none of you can afford wine because you're paying for your new college tuition. But once you get a job, you can drink fancy wine because they serve it at your work, because you'll be paying for rent in San Francisco, which is now really expensive. But the point here is Pinot Noir and Zinfandel are 2 great types. They both grow around here. Well, Pinot Noir not so much, but Zinfandel grows around here. Pinot Noir a little bit north and a little bit south. They're delicious wines. I like both of them very much. Not in fixed proportions. Don't